Hi, this is Johnny Shannon from Geospatial Insight, and I'm here with a little bit more information on spatial modelling. Last time we were looking at how we could get useful information from Sentinel-1 data. We had a stack of Sentinel-1 data over a time period of one summer. We had some field boundaries, and we put all those together so we could get the mean value of the Sentinel-1 stack for each band over each of those field boundaries, and then we could output that. I said at the time I'd be going back and having a little bit more of a look as to what was going on in the iterator operator here, and so let's do that to start with. In order to get the zonal mean, we'd use the zonal mean operator, and for that we need a zone raster, that's our field boundaries converted to raster. We need a class raster, that's our stack of our 3 input Sentinel-1 images, and the output from that we'll get a zonal mean. Now we could just take each individual band individually and do 3 of these, but it's neater if we use the iterator operator. So I'll get rid of this and I'll show you what's going on in there. From here we get the raster information, and that gives us how many bands we have in each of or on our input data. So we got 3 bands in here, and then we feed that into a dynamic table input, and that outputs a table with 3 values, that's our 3 bands, starting at 1 and incrementing 1, so 1, 2, 3, the number of bands we've got, and that feeds into our iterator operator. That's essentially a little submodel where we have our input of our zone raster, our multi-layer raster, our class raster, and our layer number. And for each of those layers, it'll iterate through, and so for band 1, band 2, band 3, it'll take the zonal mean, and then using the direct lookup, feed that value back to the zone raster and output. And then we stack all those layers together and output to the preview, which is what we were looking at before. I will do that, but before we actually run this model properly, there's something else that would be useful to do. It might be a good idea if we do some work with the field boundaries. At the moment, those are running along the edges of the field and there's no gap between them. Around the edges of the field, you're quite likely to have mixed pixels, and if we can get rid of them, that would be good. So if we have a look down here, I've got some operators I prepared earlier, and what this is going to do is to inwardly buffer from the field boundaries. And so if we hook the field boundaries up to the features there, I'm going to find out the pixel size of our stack there, and then I'm going to negate it. So we're going to basically go 1 pixel in for each of these zones. And then in order to convert to raster, just for neatness, I can set the zone raster as the same pixel size as the input there. And so if we, I'll preview this and run this with a super fast cut to avoid the minute or so it's for processing. And now we can see that the output we have here, it's got gaps between the fields, and hopefully the mean value that we have for each of these field boundaries is going to be a little bit more pure and avoiding the edge pixels around the edge. So that's fine. The values we're getting here are the means of each of these bands. That's fine, but it'd be better if we could get some more information out of that. And so one of the ways we could do that is to classify this output data. And a simple way to do that would be to use an unsupervised classification. Now there's a couple of things here. I've got something prepared earlier which converts our output file name there into a output file for unsupervised. Basically it just appends unsupervised to the file name, and so we can hook that up to the output file there, and then we can output the stack to there, and then we can run the unsupervised classification. And that takes about 30 seconds, but we can now load that up into this viewer. And now we can see that we have the unsupervised layer here. And if we look at the values, then we're looking at class 25 there, and class 25 there, class 3 there, and then all this, class 2. And so essentially, this has grouped similar fields from the stack of Sentinel-1 data together, and hopefully some of those classes will relate directly to the types of crops that are being grown in those fields. There it is. I hope that's useful. Over the last couple of tips, we've seen how we can take a stack of Sentinel-1 data and get some useful information out of it. If you have any queries, then let me know in the comments. And if you'd like a copy of the model, then why not send us an email, support@geospatial-insight.co.uk. And that's all for now. Until the next time, bye from me.